Hey everybody, and welcome back to another edition of, me reteaching you the math lesson you learned today. Today we learned about dividing whole numbers by unit fractions. Let's just remember two things before we start. First of all, a whole number, I should always get my pen ready before I start. Whole number is any number that has all of its parts. A fraction is a part of a whole. A unit fraction has a numerator of 1 because it's literally standing for one of those pieces of a fraction. So it could be a half, a quarter, a third, anything as long as the numerator is 1. With that, let's get started. Okay, so once again, we need to make sure we're reading questions carefully and we understand what we're looking at first. If you just start attacking things and plugging in numbers, nothing's going to go right. So what do we have here? We have one ball of dough. It can be stretched in a circle to make a pizza. Congratulations. After the pizza is cooked, it's cut into 8 equal slices. So, what am I thinking here? I'm thinking this picture. I have one ball of pizza cut into 8 pieces. So what do I know so far? I know that one pizza is cut into eighths. 8 slices, one pizza. Even right. One pizza equals 8 slices. About how many slices can you make with 3 balls of dough? So I'm changing something here. I'm changing the 1. Now I'm going to have 3 pizzas. Before I start this, I have to realize 2 things. First, I had to divide. Whoa, hey now. That was supposed to be a pointer. I realized that I have a ball of pizza. It's cut into 8 slices. I divided it. I shared it. I cut it up. What does that mean? I'm dividing. What else did I realize? I'm realizing that there's one pizza is divided into 8 slices. But I have to remember something else. That's just one pizza. I also have to remember that whenever I divide, it's what I have divided by what's being done or how it's shared. So I have 3 balls of dough. So this was great for 1 being cut into eighths, but now it's 3. So setting up the problem correctly, I'm going to have 3 balls of dough, and they're still all getting divided by eighths. That hasn't changed. Now, I do the algorithm straight up. I have 3 over 1 because there are 3 wholes. That stays the same. I then take the inverse operation of division, which is multiplication, and I take the reciprocal of the fraction. So instead of it being 1/8, it's going to be 8 over 1. And why is that again? That's because this fraction represents that one piece out of the whole. The whole is cut into 8 pieces, and you get 1 of the 8 pieces. Here, this says that in one whole, like the pie, there are 8 pieces. And since I have 8 pieces in one whole, I can then multiply it by the 3 wholes of dough that I have. So, do the math. 24 over 1, which is 24 slices, not 24 pizzas. You have to make sure that you know the right words. All right, sushi. I had this for lunch the day that we did this. That's funny. Joyce is making sushi rolls. She needs a 1/4 cup of rice for each roll. So, 1 roll, 1/4 cup of rice. How many sushi rolls can she make if she has 3 cups of rice? And again, now here they gave us a little picture to look at. I like that. If I didn't have this picture, the first thing I would have done was I would have said, oh, I have 3 cups of rice. I'm going to draw 3 cups of rice. Then what did I know? Well, by the way, I had 3. And I was dividing it into what? Well, for 1 roll, I needed a 1/4 cup, right? For each roll. So 1 is a 1/4. So I'm going to divide my 3 wholes by 1/4. And if I'm doing that over here, I'm dividing each into a 1/4. I need less than 1. Again, I'm just going to take what I have. I'm going to take the inverse operation of division, which is multiplication. And instead of showing that I need 1/4 of the cup for a whole roll, I know that in 1 cup of rice, I will be able to get 4 sushi rolls. So if I have 3 cups, and in each cup I can get 4 rolls, I know that I'm going to be able to make, 12 rolls of sushi. And that's over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Delicious. All right. They want me to use this diagram to show how 4 divided by 1/3 equals 12. So, first thing I notice, I have 4 holes. Here's a hole, and I know that they're holes because they're separate. They're not touching, so they're holes. Boom. I have 4 holes. Each hole was then cut into thirds. So 4 divided by 1/3, I needed to take the inverse operation, the reciprocal. I should have 12 pieces, and here it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One other thing I want to remind you of, we see a larger value than what we started with. But don't be confused. It doesn't mean that we have more of something. If these were all pizzas, right, 4 pizzas, I don't have 12 pizzas now. I have 12 slices of pizzas. The value decreases when we divide. Okay, so I have more pieces, but that value technically isn't greater. What that really stands for is that 4 pies equal 12 slices. All right. We need to pay attention to how we read the problems. This says, how many thirds are in 3? Again, we have to remember what we have divided by how it's shared or divided. What do I really have? I have 3. I'm dividing it by 1/3. One, 2, 3. Can you hear my baby screaming in the background? That's what happens when your kids are watching her for 5 minutes. All right. Each of those holes gets cut into thirds. Here they are. 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. I'm sorry about that. That should have been cut there. Looks much better now. And then we're going to take a look at the second question. Again, remembering I have to set it upright. If you don't set it upright the first time, it's already game over. Speaking of game over, no music again today. Sorry. In the middle of report cards too. All right. Here we go. How many thirds are in 6? In 6, I have 6. I'm dividing it into thirds. All right, so here we already know the 6 holes. We can see them. Oh yeah, I forgot to have a pointer. You can see them. 1, 2, 3, 4, 5, 6. Each one is getting cut into thirds, or 3 pieces. The denominator tells you how many pieces are in a whole. Remember, vocabulary is the most important part of math. If you don't understand the words you're reading, you're not going to comprehend what to do. All right. I can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Which makes sense because, as we've noticed in prior lessons, I can multiply my denominator by my whole number and still get the answer, because that's what's going to happen once I take the reciprocal. So I had 6. I was dividing it by 1/3. I took the inverse operation. I took the reciprocal of the second number. And I should get 18 slices. Or pieces. How many sixths are in 1? I'm only concerned with 1 whole. Well, if I cut it into sixths, I have 6 pieces. But then how many 6s are in 5? I'm using 1, 2, 3, 4, 5 of these. Each of these 5 have 6 pieces. Once I know how many are in my unit fraction, I can just multiply the 2 together. Because if I know the value of 1, I should be using my pointer. If if I know what the value of 1 is, the only thing that changes is how much I have, right? So if I know that in 1 I will get 6 pieces, and I have 5, well, I know that's just 5 times 6. That's why unit fractions are really important. Once you know what's in 1, you can figure out anything else, no matter how many you have. Finally, really good word problem to do because it's going to show you how you need to read it in context of a story to set it up. Again, it's nothing more than what I have divided by how it's divided or shared or split up. Dan has, oh, they give it to you nice and easy. He has 4 cartons of juice. He pours 1/8 of a carton for each person. Each is meaning it's going to be the same value for every person. All right, on a camping trip, how many people can he serve? Draw a picture to help you answer your question. Well, let's do the algorithm first because I already set it up. I know that I had 4 full cartons of juice. Each of those cartons, meaning one of those cartons, had 8 servings because each carton was broken into eighths. So if I took the reciprocal, I would know that there were 8 servings per carton. The only thing that's different is I have 4 cartons. So he should be able to make 32 servings. And then if I had done that, I mean, I always think pizza when they do eighths, but that's kind of like pizza. Very fattening, though. Very fattening. Delicious. If I cut each in the eighths, you're going to see, and I'm not going to count it out because 32 is such a large number to count, that you would have 32 pieces. Feel free to pause it to count it to double check, but there it is. Ladies and gentlemen, thank you so much for hanging out with me again. I hope these are really helping you. I'm having fun doing them. Again, unedited, uncut. If I made any mistakes, I'm sorry. They're in there forever. See you in class.